Welcome back to Physics with Miyoshi. Today we're going to talk a little bit about ideal gas law, but before we get to that, you ever thought about how many molecules of water there are in an 8-ounce glass of water? Well, we'll come back to that a little bit, and we need to figure out about molecules and a thing called molecular mass and something called Avogadro's number. So those are how we'll start out our discussion about, and then eventually get to the ideal gas law. So atomic mass is what you see in the elements of periodic table, and a periodic table of elements. And the way they figure that out, it's the units is just a U for the atomic mass unit, and 1 U is 1.6605 times 10 to the negative 27 kilograms. And the way they figured that out was they figured out, well, we're going to use the most common element, carbon-12, and what we're going to come up with is something called a gram mole or a mole. It's abbreviated MOL, believe it or not. And 1 mole of a substance, the definition of that is how much it contains. 1 mole of a substance contains as many particles or atoms as there are in 12 grams of carbon-12. So what does that really mean? Well, if I have a mole of carbon, it's going to weigh 12 grams. On a mole of hydrogen, it's going to weigh a certain other weight, and a mole of, which is about 1.00794 units and atomic units, and a mole of sulfur is going to be something else. So a mole of oxygen will be whatever it would be, 15.9994 atomic units. But regardless of that, a mole, it's the same amount, they're all going to have the same amount of atoms, or the same amount of molecules. And that number happens to be 1 mole, and that mole is a number that is very large, 6.022 times 10 to the 23rd. And the reason we say particles or atoms, because there are things like hydrogen that don't exist by themselves as a singular thing. It's hydrogen, there's 2 hydrogen atoms per hydrogen molecule, just like there's 2 hydrogen atoms plus 1 oxygen atom in a water molecule. So that number happens to be Avogadro's number. We abbreviate it NA. And Avogadro is named after the Italian scientist. So Avogadro's number is 6.022 times 10 to the 23rd, a number I've remembered for many, many, many years. I don't even know why I remember it, except for using it a few times in physics long ago. We can also figure out the number of molecules by knowing the mass of the particle, and knowing how many molecules there are in Avogadro's number. And if we can know how many particles, if we can multiply the mass times the particle mass, or the particle mass times the number, we end up getting the mass. And if we divide that by the mass per mole, we can then find the number of particles in any substance that we know what the substance is. So, and one part of the reason that we can do that is because if we look at the periodic table of elements, we can see the atomic mass, and that mass, even though it's in atomic mass units, we can also convert that to grams, and that the grams per mole. So that those Avogadro's number, 1 mole of carbon atoms, again weighs about 12 grams, and 1 mole of the other elements would weigh however many grams are in the element periodic table. Okay, so back to that question, what about our glass of water? Well, if we come back, how many particles are in a glass of water? A glass of water is approximately, well, a definition of a glass is fluid, 8 fluid ounces, which is about 236 milliliters, which I rounded up to 240 milliliters to make these calculations. So if I have 240 milliliters of water, at the right temperature and pressure, that's around 240 grams. So I know that hydrogen and our water is made up of hydrogen and oxygen, 2 parts hydrogen, 1 part oxygen, and I can look on our periodic table of elements and see that hydrogen is 1.00794 atomic units, or grams per mole, and oxygen is 15.9994 grams per mole. By the way, you would wonder why this wouldn't be just 1 and 15. Well, the reason why is because they take into account that all the hydrogen is not one type of hydrogen. There are many types of hydrogen. There's isotopes, which are different variations of hydrogen, different variations of oxygen as well. And back to our carbon, there's different types of carbon as well. So I know there's 2 parts hydrogen, so I'm going to multiply the 2 times my atomic mass there, and I'm going to add into that my mass of my oxygen, and I end up getting 18.01 blah 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 grams per mole for water. Now if I want to find out the number of molecules in my glass of water, all I have to do is multiply, or number of moles rather. If I want to find the number of moles, I just divide my, I take my mass, divide that by the mass per mole, and I find that the 240 grams, that we looked up before, divided by my 18 grams per mole, it's going to give me about 13.322 moles. Well, I know from remembering Avogadro's number, if I just multiply my number of moles times my Avogadro's number, that'll give me my number of particles. So when I do that, 13.3 moles times 6.022 times 10 to the 23rd particles per mole. The book I use actually uses, they mention that particles or atoms are not technically SI units, so they just get rid of the particles. But we end up having 8.02 times 10 to the 24th particles. So there are 8.02 times 10 to the 24th particles of water in this 8-ounce glass of water, and every time you drink it down, you'll be drinking down that many particles of water. Lots of particles, not really a lot when we think of it in big terms. So, a little bit about Avogadro's number, a little bit about particles, and a little bit about atomic mass units on our way to learning about ideal gas law. And if you've ever wondered how many particles, you can calculate that, how many particles there are in a glass of water. And boy, I'm getting thirsty talking here, so I'll have my little glass of water, and hopefully you'll tune back in later for more Physics with Miyoshi. Thanks again for tuning in.